Hey everyone, welcome back. Today, we're going to learn how to call stored procedures from Spring Boot using JdBc. Stored procedures let us run complex SQL right in the database, which is faster and more secure. I'll show you how to use JdbcTemplate to call these procedures, send data to them, get results back, and use them in your Spring Boot app. Let's get started. Alright everyone, today we're going to make a stored procedure that does the same thing as our fetchEmployee method. We're not going to change any of our existing Java code, this will be separate. Like our fetchEmployee method, this stored procedure will filter by employee name and department only if they're given. It will also handle pagination. It takes 4 things: employee name, department, page size, and page number. Alright everyone, let's make a new file called fetchEmployee.sql in our DAO module. We'll put the stored procedure code for getting employee records in this file. Alright everyone, let's write the stored procedure code together. We're not going to talk much about how stored procedures work today, because we're focusing on how to call them. First, let's drop the stored procedure if it already exists. Type drop procedure if exists fetch_employees. The last thing is the procedure name, and we're calling it fetch_employees. This is important. The name of our procedure is fetch_employees, but the file is called fetchEmployee.sql. Remember, you can name them differently. Now, we need to set the delimiter. This tells SQL that $$ marks the end of our procedure. Now, we'll write the command to create our procedure. Type create procedure. And next, procedure name, I'm keeping it as fetch_employees. Now it's time to define our input parameters for the stored procedure. When taking input, we start with IN followed by the variable name and then its type. So, let's add our parameters in order. First employee_name. Then department. Followed by page_number. And finally page_size. Watch as I type this out. Alright everyone, we've taken our input parameters. Now it's time to write our procedure logic. We'll wrap our code between begin and end so that everything inside is executed as part of our stored procedure. Type it exactly as I have typed it. Now let's declare 2 variables inside our procedure. The first one is condition_query. Of type text, which we'll initialize to a blank string. The second is conditions. Of type varchar. And we'll set its default value to where. Now let's type out an if condition to check if employee_name is not null and not blank. Watch how I type it on my screen. Now we're going to add our employee name condition to our query. Now let's concatenate the conditions. We have our conditions variable, which contains where, and we need to add the employee name condition into our condition_query. Watch me as I type. I'm using the quote function to safely append the employee_name value. This makes sure that the value is properly enclosed in quotes in our final query, keeping things safe and SQL injection free. You could also build a dynamic query using placeholders like question mark, just like in a prepared statement. But as you might imagine, that approach creates a lot of if-else conditions in the procedure. I'll show you a similar approach later for handling limit and offset. Now, we're changing the conditions variable to AND. This makes sure any other conditions we add are connected with AND. Now we'll do the same thing for the department. Now, we need to make a query that counts how many employees match our search. Now you see we're using the @count_query variable. This is key for dynamic query building. Using this syntax allows us to build our SQL count query dynamically. This provides flexibility and avoids hardcoding. Build a select count * from employee query and then append our dynamic condition_query to it. Follow along as I type it out on my screen. Now that we have our dynamic count query built in at @count_query, it's time to execute it. First, we'll prepare a prepared statement from @count_query. Next step, execute this prepared statement. Next, we need to deallocate the prepared statement. After executing it, we don't need it anymore, so it's important to free up those resources. And remember, when we execute the statement, it returns a result set. This result set is then used to get the total record count, which is essential for our response and pagination logic. Alright everyone, next up we need to create the actual query that will return the employee records. We're going to build this query dynamically as well, similar to our count query, but this time, we'll select the employee data instead of just counting records. Alright everyone, first let's assign the page_size to a variable. I'll call it @var_page_size. We're doing this because we'll be passing it dynamically into our query later on. Watch as I type this out on my screen. Next we need to calculate the offset and assign it to a variable named @offset. Now let's build our query just like we did with the count query. But this time, we'll be selecting employee records. Append the limit and offset and their corresponding placeholders to our query so that we can pass those values dynamically. Watch as I type this out on the screen. Next we're going to create a prepared statement for our employee query. Execute this statement by using our @var_page_size and @offset variables to replace the placeholders dynamically. Deallocate the statement to free up the resources. Alright everyone, now that we've executed the employee query, it returns another result set containing our employee records. We'll use this result set to map the data into our employee objects. Alright everyone, our stored procedure is complete. Now, let's open Jdbc to check it out. Now select the whole script and click Execute Script. As you can see on my screen, it's all highlighted, This ensures that the entire stored procedure is created in one go. It's executed successfully. Now, refresh your database in Jdbc to see the changes. Now that we've made the stored procedure, you'll see fetch_employees in the procedures list. Let's execute our stored procedure using Jdbc. Right-click on fetch_employees and choose Execute Stored Procedure. Now, let's pass our input parameters. Set employee name and department as null. Page number as 0. And page size as 5. Now, hit Execute. As you can see on my screen, we've got two result sets. The first result set shows the total count of matching records. And the second one displays the employee list for the first page. Alright everyone, we've successfully created and run our stored procedure. Let's integrate it into our application. Now, let's call it from our code using JdbcTemplate. First, we'll make a new class called Demo JdbcTemplate repository. Copy the fetchEmployee method signature into this class from employee JdBC repository. Inject JdbcTemplate using constructor injection. Alright everyone, now we're going to write the query to call our stored procedure. Type it exactly like I do on screen. To call the procedure, first type call. Then the procedure name. Followed by the parameters. See, our fetch_employees procedure takes 4 parameters: employee name, department, page number, and page size. Now let's add the placeholders for our parameters in the query. We need to have 4 placeholders for employee name, department, page number, and page size. Our query is complete. Now, we'll call it using JdbcTemplate's execute method, which takes our query and a callable statement callback to handle the stored procedure call. Now we pass our query as the first parameter. Next, we need to pass a lambda implementation of callable statement callback. Now let's set all the placeholder values using our callable statement. First, we set the employee name parameter. Then the department. Followed by the page number. And finally the page size. Now let's call the execute method on our callable statement. This method returns a boolean indicating whether there's any result set returned by our stored procedure. Watch as I type this out on my screen. Now see on my screen, we're first returning the total record count from our stored procedure. So, we need to get the first result set and extract the total record count from it. Let's write the code to do that. I'm wrapping our result set handling in a try block. This guarantees that the result set gets closed properly even if something goes wrong. Now let's extract the total record count. Since our first result set contains only one column. Now that we've processed the first result set for the total record count, let's check if there's another result set available. If there is, retrieve it. The second result set contains our employee data. Use our employee row mapper to convert the rows into employee objects. Now that we've fetched the employee data from the second result set and converted each row using our employee row mapper, we've added all the results into our list. The next step is to wrap everything up by creating a page response object. Pass in our employee list
the page number,
next page size, and finally total record count. I'm running into an ambiguous method error with the JdbcTemplate to execute call. This happens because there are two overloaded methods, and it's not sure which one to pick. To fix this, we need to explicitly cast our lambda to the callable statement callback type. Okay, our code is complete and we've successfully integrated the stored procedure call with JdbcTemplate. Now, let's move on to the next step, writing our controller code. Create a new class called DemoJdbcTemplateController. Now let's annotate our controller class with @RESTController. Now copy the API signature of fetchEmployee from the employee controller into our controller. Map our fetchEmployee method to /procedure/demo path. First, let's inject our demo JdBC template repository into our controller. Now let's copy the code from our employee service fetchEmployee method into our controller method. Send page size to 5, or any number you want. Now we also need our entity DTO mapper to convert our entities to DTOs before sending the response. Let's inject that into our controller as well. Next, return the employee list response. Our controller method is complete. We call our new fetchEmployee method, which invokes the stored procedure, converts the results into employee objects, and returns the response. Now, let's start the application. Okay, our application failed to start. Demo JdBC template repository bean wasn't found. Oh, that's right, I forgot to add the @repository annotation on our repository class. Restart the application. Okay, open Postman and hit our new API endpoint. It looks like we ran into an error. Ah, I see the issue. I've forgotten to call rs.next to move the cursor to the first row of our result set. Without this, we're not actually reading the total record count correctly.
Fix this.
And restart the application again. Hit the API again. Alright everyone, see that? We got a successful response, 5 records returned with a total of 5 pages. And if you try it with page 2. Alright everyone, I know that calling stored procedures using JdbcTemplate to execute with a callable statement callback can get pretty complex and messy. But guess what? There's a simpler, more elegant way, using simple JdBC call. With simple JdBC call, you can call your stored procedure with just a few lines of code. It drastically reduces the boilerplate, letting you focus on what matters, your business logic. Plus, it makes your code much cleaner and easier to maintain. In our next segment, I'll show you exactly how to use simple JdBC call to call a stored procedure. Let's get started. I'm going to copy the method signature from above and paste it right below, so we can use it with simple JdBC call. Now, we're going to make our simple JdBC call object. Type this exactly like I do. Start by making a new simple JdBC call using our JdBC template. We tell it the procedure name is fetch_employees using .with procedure name. Use returning result set method to map the first result set. This one returns our total record count. We'll map it to a long and pass a key name for it. In our returned map, this key will be used to access the total record count. I use the key total records. Then, we use another returning result set to map the employee list using our employee row mapper. I am using the parameter name as employees for second result set. Alright everyone, our simple JdBC call object for the fetch_employees procedure is all set up. Right now, I'm creating this object inside the method, but here's a pro tip: you can define it at the class level. This way, you won't have to create it every time the method is called since the configuration remains the same for every call. Now let's create a map_SQL parameter source object to hold all the input parameters for our stored procedure. Now it's time to add our input values using the addValue method on our map_SQL parameter source object. This method takes two parameters, the param name and the value. Remember, the param name must exactly match the names defined in our stored procedure. So first, add employee_name.
Next department. Then page number.
Finally, page size. Now it's time to execute our stored procedure call. Call execute method of our simple JdBC call. And pass the map_SQL parameter source object that contains all our parameter details and values. This call will run the procedure and return a map with our result sets. In our simple JdBC call, we've already specified that the first result set is mapped with the key total records. This returns a list of data for each key, even though we expect only one record for the total count. So, to get our total record count, we simply extract the first element from that list. Now let's talk about our second result set. We've mapped it to the key employees using our employee row mapper. This means that our stored procedure automatically fetches all the employee records, converts each row into an employee object using the mapper, and then puts the list of employees in our result map under the employees key. This makes it super convenient to access all our employee data directly. Now let's fetch the employee list from our result map. Create a new page response object that packages our employee list, page number, page size, and total record count and return. Rename this method name to fetch employees with simple Jdbc. Now open demo JdbcTemplate controller class. Call this method instead of fetch employees. Now, let's restart the application. Now switch over to Postman and hit the API.
Check our response.
We got a proper response for page 1 with 5 records, and it correctly returns the total number of pages. This confirms that our stored procedure call using simple JdBC call is working perfectly. Let's hit the API again with page 2. Check it out, our response now shows page 2 data correctly. Alright everyone, let's wrap up this session with a quick summary. We successfully built a stored procedure to fetch employee records with filtering and pagination. We mapped our result sets, one for total record count and one for the employee list, using simple JdBC call and our employee row mapper. Then, we extracted these values from the returned map and wrapped everything in a page response object. Finally, we tested the API in Postman for page 1 and page 2, and everything worked perfectly. In our next video, we'll learn how to execute operations in batches, like batch insert or update, to further optimize our application. Thank you for watching, and don't forget to subscribe and hit that notification bell.
See you next time.